Hello everyone, today we will be talking about the metallic bond as well as the vanderwaal forces, which are the attractive forces also known as the intermolecular attractive forces. So we start with the metallic bond. What is exactly a metallic bond? A metallic bond is a bond which exists between the positive metal ions and the electron cloud or electron gas. Now what is the electron gas? The electron gas is the negative electrons, and the population of all those negative electrons is known as the electron gas. And we know that there is a force of attraction between two opposite forces. So you have these positive metal ions and the electrons, population of electrons or the electron gas. Now these positive metal ions are also known as kernels, Kernels. So now these kernels, basically they are not moving. They have fixed positions. However, the electrons, they move from one place to another. So you have a diagram, you have these positive metal ions, and then you have the electrons which are donated by the dots. So these electrons, they move to and fro inside the metallic bond. So this attraction between the electrons and the positive metal ions is known as the metallic bond. Now the metallic bond are non-directional, as we have seen in the diagram. They are non-directional. The characteristics of metallic bond. Now the metallic bonds have the characteristics similar to a metal. So that means they have high BP and MP. Secondly, good conductors of heat and electricity. And they are hard, mostly, because you know some metals which are not hard. Now this is all that we have to know about the metallic bond. Now we are going to discuss the intermolecular attractive forces. Intermolecular attractive forces, also known as vanderwaal, VANDERWAAL. Basically, these two words are together. So, what are van der Waal forces? The van der Waal forces are the intermolecular attractive forces between two molecules. You have two molecules, and it is the attractive force, the intermolecular attractive force, when these two molecules are close to one another. Imagine you have the sketch pen and this pen pencil, they are close, they are molecules, they are close to each other, and this attractive force between them is known as the intermolecular attractive force. These forces are weak because as you may be thinking that if there's two electrons, then why is it that everything in the world, everything in the universe, they have attractive, the van der Waal force. However, this force is weak, but in some molecules it is stronger than the repulsive force. Now what repulses these forces? It is the repulsive force between electron clouds of adjacent molecules. I write it down. Repulsive force, electron cloud, electron gas of adjacent molecules, and secondly, repulsion between nuclei of neighboring atoms. However, the attractive forces are stronger than repulsive forces. Now there are type of van der Waal forces. What are they? Number one, you have the dipole forces. Number two, you have the London forces, London. Yes, it is London. Then you have the hydrogen bond. What are dipole forces? Dipole forces are the forces which act on the molecule when the positive end of one molecule is near the negative end of another molecule. So you have a molecule, the end, this is a molecule, and you have the positive end, and then you have another molecule and you have the negative end. So these are the forces, dipole forces, when the positive end of one molecule is near the negative end of another molecule. You have examples like HF, HCl. These are the dipole forces. Now the London forces. What are London forces? Basically, London forces are weak forces between molecules resulting from the small instantaneous dipole that occur because of varying positions of electrons during their motion about the nucleus. So these forces, as you know, the electrons, they keep on moving. So you develop attractive force because of the varying position of electrons, and they occur in all the mu molecules, but because they are weak forces you do not notice much difference. These are the London forces, and they increase with increase in the molecular weight, so they are directly proportional to the molecular weight. Thirdly, you have the hydrogen bond or the hydrogen bond. So when you have a hydrogen atom covalently bonded to a highly electronegative atom, okay, I'll write it down. You have the H2 atom bonded with maybe X, okay, it is bonded to a highly electronegative atom and a lone pair of electrons on another small electronegative atom. So you have this bonded to a lone pair of electrons on another electronegative atom, and this is known as the hydrogen bond, also referred to as the hydrogen bridge, and it is denoted by dotted lines. So you may be having H2O, HOH, water molecule. Now there are two types of hydrogen bonds. Number one is the intermolecular hydrogen bond. Number two is the intramolecular. Now, as the name suggests, the intermolecular is the electrostatic force of attraction between hydrogen atom and electronegative element of two different molecules. So you have two different molecules, and it is the force of attraction between two molecules. However, intra, as the name suggests, it is the attractive force between the electrostatic force of attraction between hydrogen atom and electronegative element of the same molecule. So you have one molecule, and then when you develop the hydrogen bond inside the same molecule itself, you call it as the intramolecular hydrogen bond. This is all for today's lecture. In my next lecture, I will be telling you about the various theories concerning the molecules. You have the valence bond theory, you have the Pauling and Slaughter theory. Now, if you have any queries, please ask your query in the comments below. And if you like this video, please do not forget to like and subscribe. Thank you and have a nice day.